Let's discuss a question from forming. A circular blank of 30 mm diameter is to be cut from 2 mm thick sheet. So you have a sheet which is of 2 mm thick, and you basically want to cut with the help of a punch. So here you have a punch, and when you apply a force, so this portion be cut and it will just appear like this, right? Okay, so if you consider the punch here, and if you draw the free body diagram of the punch during the cutting, okay, so let's say this is your steel plate. Okay, so when it cuts and when it goes through this entire, okay, so this portion of the punch throughout the circumference, so that portion of the punch throughout the circumference will experience the shear force. Basically this portion of the punch throughout the circumference and for the entire circumference and for the depth of thickness, this area will experience resisting force by this metal, because it's trying to shear off. Basically there will be a tangential force that will be applied on this punch, so that force will be there throughout the circumference and it will be in this direction. Okay, it will be all throughout the thickness, throughout the circumference, in that portion of the thickness. So let that like when it is failing, obviously the stress will be tau there, because it's trying to shear off, so it will happen only at the ultimate shear. So ultimate shear into the area of resistance is what is the opposing force from the metal, and this has to be equal to the punch force in order to shear the metal, right? So you need to apply externally that much force which your metal applies, which your metal resists in the form of stress into area, is what you have to apply. So the punch force is P tau into A. Tau is the failure strength, because at that time the material actually fails, and area of resistance is actually this thickness into this circumference, because that is the area where it resists. So 2 pi r into the thickness is the area of resistance. The punch force is tau, 2 pi r, 2r I can write as d, so pi d into thickness. Tau is basically, tau is my shear strength 310 MPa into pi, diameter is 30, thickness is 2. So I have diameter and thickness in mm, and this tau is in MPa, Newton per mm square. So ultimately when I multiply, I'll be getting in newtons. So 5843 newtons, 58430 newtons. So roughly 58.43 kilonewtons. So 58.43 kilonewtons is what is the punch force you need to apply in order to execute this task. This is basically a question from strength of materials. Thank you.